Okay, so we have to graph this equation. This equation is linear in both x and y, therefore the graph is going to be a straight line. However, due to divisibility issues, there is going to be an interesting complication in this problem, namely that the x and the y intercepts, none of them is going to be an integer. This is because if we put in x equals 0, then we get 2 times 0 plus 3y equals negative 5. That's the same as 3y equals negative 5. We solve for y. So y is negative 5 over 3, which is the same as negative 1 and 2/3. So what we found is the point 0 minus 1 and 2/3. That's not a very pretty point because the second coordinate is not an integer. We get better precision if we only use points of whose both coordinates are integers. Such a point is called a lattice point. We will get better precision if we use lattice points. So the question is, how can we find lattice points? So the first thing that we need to do is keep trying. After x equals 0, we're going to try 1 and 2 and 3 and so on until we run into a nice number. What we did here was we divided by 3, and that means that we're going to run into a nice lattice point at worst the 3 try. So every third number will behave nicely. So let's see if we get lucky if x is 1. If x is 1, then the equation 2x plus 3y equals negative 5 becomes 2 times 1 plus 3y equals negative 5. That's the same as 3y plus 2 equals negative 5. It looks like we're not getting lucky right now. We're going to subtract 2. 3y equals negative 7. And divide both sides by 3. So we get y equals negative 7 over 3, which is the same as negative 2 1/3. So it's not pretty. Negative 2 1/3. So if x is 1, then y is negative 2 1/3, somewhere like this. Now that we tried x equals 0 and 1, the third number will work. So my prediction is that both negative 1 and 2 will work for x. Let's see x equals 2 first. So if x equals 2, then the equation 2x plus 3y equals negative 5 will become 2 times 2 plus 3y equals negative 5. So that is the same as 3y plus 4 equals negative 5. And we're going to solve this two-step equation for y. We're going to subtract 4 and divide by 3. When we subtract 4, we get 3y equals negative 9. And when we divide by 3, y equals negative 3. So we did find a lattice point. The first nice point or lattice point is 2, negative 3. So we can graph that. If x is 2, y is negative 3. That kind of confirms our, or at least doesn't contradict our previously found points, but this will give us better precision. So once we found a point a number that behaves well, then we need to add or subtract a multiple of whatever we divide by. Now if x was 0, we divided by 3. If x was 1, we divided by 3. If x was 2, we divided by 3. That's because for every value of x, this will become a number. So we get 3y plus a number equals negative 5. So no matter what value of x we use, we always divide by 3. So sort of finding a lattice point hinges on divisibility by 3, which means find one nice point and then add 3 or subtract 3 to the x value. X equals 2 worked. We can also use the graph to sort of, if x equals 2 worked, then the next one is with x equals 5. We might be barely in the picture, but it's probably worth trying. So if x is 5, then the equation 2x plus 3y equals negative 5 will become 2 times 5 plus 3y equals negative 5. Well, that is the same as 3y plus 10 equals negative 5. And that's a two-step equation that we're going to solve for y. We're going to subtract 10 and then divide by 3. So we get 3y equals negative 15. And when we divide both sides by 3, we get y equals -5. So what we found is the point 5, -5. We put in x equals 5, we got y to be -5. So we can plot that. We made it. It's still in the picture. 5, -5, right here. So we found x equals 2. We added 3 to it to get another nice point. We can also subtract 3. So the next number that will give us a lattice point is x equals -1. So let's see what we get if we put in x equals -1. If x is -1, then the equation 2x plus 3y becomes 2 times -1 plus 3y equals -5. That is the same as 3y minus 2 equals -5. So this is a two-step equation. We're going to solve for y by adding 2 and dividing by 3. We add 2, then we divide by 3. And so what we got is that if x is -1, then so is y. We found the point -1, -1. Does that make sense? Well, it looks like that it is in accordance with the points that we already found. If we want to find another nice point, we should subtract 3 from -1. So -4 will work nicely again. So if x is -4, then 2x plus 3y equals -5 will become 2 times -4 plus 3y equals to -5. That's the same as 3y minus 8 equals to -5. This is a two-step equation for y. We're going to solve it by adding 8 and divide by 3. So we're going to add 8. Then we get 3y equals plus 3. And finally, we're going to divide both sides by 3. And we get y equals 1. So what we found is that if x is -4, then y is 1. So we found the point -4, 1. It looks like we have plenty of points. They all seem to be on the same line. So we can just put a ruler through it and connect the dots. Thank you for watching.